Dear all, I am Dr. Enis Karaslan from Muğla Koçman University, Department of Computer Engineering. I am head of the cybersecurity discipline, and I am also a member of artificial intelligence discipline. So today I will talk about our study on digital twin security threats and countermeasures, and I will give you an introduction to that topic and our views on that subject. First of all, we will start with the digital twin, right? The digital twin is described as a digital copy of any physical entity that's being updated with real-time data constantly from physical world. And digital twin is not only a model-based simulation and optimization, it includes real-time transmission and analysis of data, and it creates intelligence to yield positive impacts on several sectors. So it has got potential in many fields: manufacturing, construction, utilities, healthcare, etc. And it communicates with these associated sensors and can work cooperatively with other digital twins as well. It has various use cases are possible for smart city, smart country, and smart world scenarios. And this paper discusses the security challenges and threats within the digital twin and suggests countermeasures and security controls. So let's start the content with the fundamentals. When we are looking at the digital twin is a virtual digital representation of a real physical system, and it can be used to predict the future states of that physical entity. It can be integrated with several other technologies such as artificial intelligence, the Internet of Things, machine learning, data mining, and cloud computing. And when we are looking at the architecture, so we have a physical asset at the physical layer and a sensor as well. And this physical layer sends data to the virtual layer. And the virtual layer is the digital twin, right? And the digital twin has a simulator software and a machine learning algorithm running on top of it. And the machine learning works on the collected data to give an insight and knowledge information and also prediction as well. And it also forms a virtual copy of the digital asset. And also this data is stored mostly on the cloud. And this virtual layer can predict and can give some decision to that physical asset and also to some other operators as well. And this is the intelligence of the physical world. And the digital twin works like this. And digital twin is connected with the physical system via various communication protocols. And these allow the information flow from and to the system sensors. And this also allows the digital twin forecasting ability for any future states of production. And let's look at digital twin security threats. There are threats to the availability, integrity, and confidentiality services, and there are threats related to the attack surface, because there are various variety of systems and technologies on the digital twin system. And there are also threats related to the real-time data usage of the digital twin. And when we are looking at the threats to the availability, these could lead to unstable systems, and also threats to the integrity of the product could lead to bias estimation and decision, which might cause high risks. So if we can list the digital twin security threats, we will just give them in this order. We will talk about the physical threats, data modification threats, system threats, software threats, data communication threats, data storing threats, and machine learning threats. Okay, when we look at the physical threats are by the interactions with the physical components. The sensors, the IoT devices can be damaged, destroyed, or even stolen by the attacker. And also we should also focus on the safety, because safety first. The defects of a critical product may lead to death, injuries, or environmental damage. When we are looking at the data modification threats, data can be modified at the source. So physical products can use tamper-proof and tamper-resistant hardware to protect their data from modification. So data modification by the attacker is still possible with data poisoning attacks or by exploiting the system, software, and data communication vulnerabilities, which we will cover in the next slides. When we are looking at the system threats, the attacker can exploit the operating system vulnerabilities to have full control over the digital twin software or to get a copy of it. And wide variety of threats and attacks with malicious programs like ransom attacks or WannaCry-based like attacks can result in a complete denial of service and heavy losses in digital twin-based systems. And when we are looking at the software threats, the attacker can exploit to obtain the digital twin software or the software source code. The software can be copied by the insiders. Poor coding could cause weak software protection. And if there is a weak or no software protection, attackers can use reverse engineering tools to obtain the source code of the system. And when they gain unauthorized access to the digital twin software or the source code, this is a very critical thing because the digital twin represents the blueprint of the real system, and the attacker will be able to analyze and know the vulnerabilities of the system. Then the attacker may further gain to access the backend systems. And there are these threats to intellectual property and trade secrets. So when we are looking also to the data communication threats, threats on the data communication may be divided into 5 main types, which we know from the network threats, which is man-in-the-middle attack, denial of service attack, or distributed denial of service attack, eavesdropping, spoofing, replay attack, and alike threats. When we are looking at the data storing threats, because the data will be stored somewhere, the stored data is sensitive and can be exposed to many risks. When we are looking at the cloud computing, if the cloud computing infrastructure is hacked, the data leaks will occur. And there are trust concerns and privacy issues related to storing the data, especially in the public cloud. So the data can also be kept in a distributed file systems solutions or decentralized storage solutions as a solution. And there are also machine learning threats. So machine learning processes are an important part of the digital twin, and they are vulnerable to security and privacy attacks, which are mostly not covered by this security measures. They are attacked mainly during training and testing inferring phases. Attacks will result in a decrease in the performance and also reliability of the system. So will be problems. So these can be classified as poisoning attack, evasion attack, impersonate attack, inversion attack. So, and these are not that much covered in the literature. So let's look at the countermeasures. When we are looking at the physical threats, we should have physical security as a countermeasure. And when we are looking at the data modification threats, we need to use tamper-proof and tamper-resistant hardware. We can use hash algorithms, blockchain, and IPFS, especially for the storage. And when we are looking at the software threats, we need to use software hardening. We need to use a secure software development lifecycle. We need to use security testing in all phases of development. When we look at the data communication threats, so we need to focus on network resiliency. We need to work on and use cryptographic solutions. We can use blockchain as an addition and firewall and intrusion detection as well. So these are mostly covered in many aspects of the cybersecurity. And also system threats as well. We can use firewall, access control, intrusion detection systems, anti-malware, system hardening, and alike solutions. These two concepts are mostly covered in the cybersecurity solutions. When we have to look at on data storing threats. We need to use cryptographic solutions, and we can focus on new techniques, especially when we are talking about big data. We need to work on cryptographic solutions which give a good performance on the big data. And when we should look at the machine learning threats, we need to work on data sanitization, algorithm robustness enhancement, security assessment mechanisms, and privacy preserving techniques as well, which I will cover in the next slides. Okay, so what are the key points? Blockchain solutions, or we should say decentralized solutions, can also be deployed to ensure trusted infrastructure, and smart contracts can be deployed to automate some tasks. And the privacy of data, or when we have the personal data, can be issued by using zero knowledge proof algorithms and smart contracts. We need to also look at homomorphic encryption. Emerging technologies should be considered when we have to talk about big data. When we have to look at the machine learning phases should be designed to defend against attacks. So we need to develop our models which are resistant to attacks on machine learning. Data sanitization and algorithm robustness enhancement should be deployed against data poisoning attacks. We should develop strong models against adversarial machine learning techniques which are used to attack the models, and we should have strong models against that. Okay, as a conclusion, many information systems heavily use Internet of Things and need decision support. And digital twins will be widely used, as this concept is not an imaginary concept anymore. So different types of digital twins will also need to communicate with their associated physical assets and also with each other as well. So maintaining the security is critical, as misuse could cause delays and problems in the decision-making process. And we need these solutions in this paper, and these digital twins consist of various technologies that are vulnerable to several attack vectors. And the countermeasures to these threats are summarized in this study. And the security of these systems, and also we started, and the industry also, and the technology is shifting to metaverse, and the security of metaverse should also be studied. So what are our future work? We need to focus on studies on countermeasures to machine learning threats, which we are now doing it in artificial intelligence discipline. So we are focusing our work on this. And also we need to focus on decentralized solutions on digital twin security. We have been studying decentralized solutions for a while, and we are also working on this topic. And also we plan to investigate in-depth threat countermeasures, building comprehensive security framework for the digital twin. And we can use blockchain and smart contracts for metaverse security as well. We are also in a process of a new book, a digital twin-driven intelligence systems, which will come from the Springer, and call for papers are still open for a few additional chapters, and you can reach it from izmiracademy.org. Okay, so we have a collaboration goal with anyone who is interested, and we like this African proverb: if you want to go fast, go alone. If you want to go far, walk together. So we want to go far, so we are always open to walk together. So thanks for listening. I hope I will make it online, but if I cannot make it online, the video will be available here. So you can reach me from my email addresses. You can add me and reach me from LinkedIn. This is also my Google Scholar. So thanks for listening. I hope I will attend it online and also answer your questions as well. Thank you.